let me introduce this next speaker. So this is one of the most interesting part also of the Open RAN domain and in the field. So following that, we'll hear from the principal consultant and solution architect for Mavenir in the Asia Pacific region about how the mobile industry needs innovation and growth to keep up with the demands of our evolving digital society and move towards a multi-vendor environment. So I'm happy to introduce to all of the engineers in the Philippines right now here about the Mavenir's lead consultant and solution architect, um, Delina Krish.
Hi, everyone. Thanks for inviting me again. Okay, thank you very much all. So today we are going to talk about RAN Intelligent Controller, which is, as Rich said, one of the key icons in the Open RAN architecture. It's mainly because, like, during my experience over the years past over the years with multiple operators, we have been seeing that they are expending like millions of dollars every year for their network optimization, mainly because it is hard and it involves lots of resources and as well as lots of expert knowledge, and the expert people is required for this radio network implementation optimization. The one major reason is the proprietary, and the traditional RAN is proprietary. So because of that, there is very less openness, and where only few people or few industry could involve and do the optimization. So the today focus is this, and what we can bring into this table, and what kind of functionalities, what kind of improvements that we can do in the network optimization domain, and what it would result to do the reduce the cost or the OPEX of an operator, and also what would be its future. So that's basically the content of today's presentation. So let me go into my next slide. So this is agenda. Let's talk about a little bit of the introduction, the architecture, and the use cases about the RIC in the first couple of topics. And let me share some of the test cases and some of the deployment scenarios that we are seeing that is happening today in the industry. And let's discuss what it would be the market or the future would be the when it's come to the RIC in future. So since that I saw that just before the previous lecture that we had the Open RAN architecture in details, so I was planning to a little bit recap those the architecture discussions, but I feel that we might not need it now, because like I saw that it was like kind of comprehensive detailed architecture discussion. So let me a little bit summarize again, just for the benefit of anyone who has joined just for this session. We have in the Open RAN architecture, we have key components. We have radios connecting to the DU and DUs, which is the first part of the baseband. And then we have the CUs. So RU is connecting via 0.7.2 interface, and the DU and CU connect via F1 interface. So CU can be in two parts, CU-CP and CU-UP. So then you have the control plane and user plane separation. So that is basically the disaggregation of the traditional baseband architecture when compared to the Open RAN solution. But the important part when it's come to the radio resource management or the radio resource management or the RIC component is like, what would be the latencies, what would be the involvement levels when it's come to the RIC functionality. So you can see, like, especially the lowest layer when it's come to the radio, that we have the physical lower layer function. So we expect, like, if you want to change anything, if you wanted to change something on the go, So we need to intervene at least less than 1 millisecond from the control from the radio resource management control point of view. So if you consider the next layer, if you are changing something in the layer 1, which is physical, the physical, but the upper layer, and MAC layer and the RLC layer, which is layer 1 and layer 2 functionalities, if you are intervene to do any changes on the go, it should be like 1 to 10 millisecond time frame that you have time to intervene. So when it's come to the LTE, one radio resource frame is 10 millisecond. So you might need to, before that you are doing that scheduling within every 10 millisecond, you might need to do any decision changes. Then when it's come to the higher layer, it's not a big issue, or at least that little bit latency relax. So what we are expecting is 10 millisecond to 1 second latency requirement. So please make sure these latencies are not for usual user plane function performance. This is for radio resource management from your SMO, service and management orchestration layer, towards these different functionalities. So so that is where that your differentiator comes into the play, the wording near real time and the non-real time. So anything that you are trying to do the near real time, that would be within 1 to 10 millisecond or better. And anything less than that we are categorize it as a non-real real time. So that is the basis of whatever that the RIC functionalities when it's come to the optimization level. So RAN function and procedures. Why this is important? When it's come to the network optimization, RAN function or the procedures are the key that you can manipulate. So if you take very basic level, so you have the radio base stations and you have a configuration file in the radio base station, and this configuration file has set of parameters. So how the UE or the base station communicate different parameters to the UE is via the RAN function and the procedures. So the example side could be handover procedure, load balancing procedure. When we come to the very latest 5G technologies, it can be beam management, it can be slice management kind of functionalities. So all these functionalities driven by certain set of parameters. So now, what has happened in this traditional world, or with the traditional proprietary vendors scenarios, none of these functionalities, or I would say very limited of those information, are open to the third party. So only those RAN specific vendor could optimize, could intervene, or could I would say develop or improve the procedures functionalities when it's come to the network optimization. Even though the 3GPP has, especially when it's come to the SON section, 3GPP has defined some certain parameters or some areas that how any vendor should open their RAN function and procedures into the third-party world. That's basically, most of them are very gray, and even there is a third-party solution provider to optimize or to change these RAN functions. Those needed very tight integration or tight testing with any of these proprietary vendors. So that made those solutions is really costly, and only few vendors, only a few third parties could survive or could provide the solution to the industry. So if you see or if you check the current who are providing those kind of the umbrella third-party solutions to do the RAN optimization, we call it SON, self-organization network. Who are the providers of the current SON providers? Is only handful of providers are there. And even though those one is they are very costly, and when it's come to the functionalities, there are very limited functionalities that you can manipulate. So that is where the MNO needed some sort of a new setup that third party can come up with very small scale, the cost effective functionalities, and also that anyone can come and play with and intervene with these third party, these RAN and function procedures. That is where the RIC architecture came into the picture. So when it's come to the Open RAN, it talk about its main concept of the base is about the openness. So then the Open RAN Alliance Work Group 2 and Work Group 3 try to introduce this RIC functionalities, non-real time and the near real time. They decide, okay, why don't we provide set of interfaces and also the set of the contract or the setup architecture that we can intervene to the basebands and try to manipulate, improve the network functional procedure. The good thing is, similar to the Open RAN, the AI, artificial intelligence, and the machine learning also getting more and more mature. So those two, openness and the AI functionalities, got combined into the RIC architecture. So what is it? So RIC architecture has three major functionalities. The first one is the SMO. So service management and orchestration function. This one is nothing but, this is not new. So if you consider very fundamental level, any network provider has a SMO function. Any traditional vendor has a SMO function, which is the lowest level is the configuration and management element. So we also call element management system or the network management system. So this is part of the SMO. And when it's come to the much wider level or the much advanced level of the SMO, that we have the slice management function or the end-to-end orchestration function, it also falls under SMO. So what it mainly do is the configuration and performance management. So if you need to do any configuration change in this basebands or the basebands, DU or the CU, or even the radios, that SMO is talked via that specific interfaces. When it's come to the Open RAN, it is ORAN interface, and you can send that message downwards and change that parameter. In the RIC architecture, what it does is, now we are introducing new functionality called non-real-time RIC. So now we have learned, if it is non-real time, so you are working within 1 to 10 or beyond 10 millisecond time frame. So the non-real time RIC is intervening in that latency environment. So what does the non-real time RIC do? So what it does is it collects information from your via the DU and the CU, specifically set of UEs, the cell level functions, slice level functions, like umbrella term, the collective of UE information are collected by the non-real time RIC. And the important part is it process offline using the AI and the machine learning, and try to understand the best way of operating. For example, it could be analyzing RSRP. RSRP is the radio resource reference power. So that is the key parameter that you are deciding whether UE is having enough radio resource, enough radio power when it's come to the UE, that whether our transmission signal is getting enough towards the UE is one of the indicated by the RSRP. And there are some other parameters called RSRQ, RSSI, those kind of different functionalities. But those information are always in the UE is always feedback towards the base station those functionalities. This is my signal strength that I'm getting. This is the neighbor cells that I am seeing. All this information are sent towards the baseband. So non-real time is collects those data in the group level or the set of UE level, or analyze in a cell, total cell level, and decide, okay, this is the best parameter for this particular cell. So the main important thing is their decision is not particular per UE. It is more of a umbrella term or the declarative function. Okay, this is the minimum RSRP threshold that should be in this cell. Okay, or this is the minimum latency should be in this cell or in this cell. And if you talk to the 5G, probably this is the minimum QoS level that should be maintained in this particular data bearer. So that kind of declarative functions are coming from the non-real-time RIC. And the next level is the near real time, which is very new. And this is the most key benefit when it's come to the RIC architecture, where that you are intervening within less than 10 millisecond time frame, and try to manipulate and especially try to grab and provide the decision real time. So it collects the information that particular UE level. So maybe he's understanding, okay, within this cell, this particular UE doesn't having enough KPIs. This particular UE doesn't have enough power to perform well, or this particular UE better to move a different cell. So his decisions are more unique, more segmented, more specific towards the UE or specific few UEs. And it takes this AI machine learning processing real time, and within very short time he is trying to do the actions. So these are the three major functionalities, and you can see that there are two elements called RAP and XAP. So what are those? So RAP and XAP are nothing but, I would say, applications that third parties are providing to do the specific functionality. Let's say the RIC platform where you have the AI and the machine learning function can be provided by, let's say, Mamani has our own RIC, non-real-time RIC, and the near real-time RIC platform. So we have our own, probably that our machine learning algorithm, the way that we are using, probably unique to us. So that defines the uniqueness or the advancement of the RIC platform. But any third party can develop RAP and XAP. So maybe one person can do the develop to optimize the handover. The other one can develop a function to optimize the energy. Third one can develop another function to do the beam management. So very specific function that third parties can develop their own version of any optimization algorithm to specific use case. So that is the beauty of this openness. People can come and play. So if you see the App Store or the Google Play Store, so how many apps that we do have for the same function? And when we are downloading, we are checking the rates, and we try to download the base function for the same application. So the same scenario that we are expecting future in the RIC, that maybe there are 5, 6, 7, 8 vendors or the third parties, small scale players are developing application to do the same optimization function. So we can choose and select the base functionality. So that helps me in my next slide. So why Open RIC? So that competition that I discussed earlier slide, that innovation that I discussed earlier slide, helped me to increase the competition and bring down that whatever the proprietary dominance within this self-organization network domain, or the automated optimization domain. So increase the innovation and also the increase the competition, bring down enormous cost reduction of the OPEX that we have to pay for the premium of this proprietary. So we believe it's obvious that when there are lots of different third parties in competing, so we believe there would be very great good scale of application would be coming to the market, will help to increase the network KPIs immensely with minimum cost. So that's what really MNOs are looking for. That's what really the companies like Mavenir, especially the people who's trying to encourage Open RAN as vendors, that we try to encourage within the industry to the market that comes, more people's come into the play and increase the variety of the network, the industry. Okay, so let's little bit try to compare, or at least try to understand much more when it's come to the functionalities that different SON or the RIC solution can provide. So the thing, when it's come to the benchmarking, if you take the multi-vendor scenarios, this DSON, distributed SON, or the centralized SON, or even the geo-based SON, so those are the previous self-organization network solutions that we had. The DSON is mainly comes from the traditional radio network provider. So those are these distributed SON means like the self-organization functionality distributed within the base station. So it is obvious that it's only that the RAN vendor can provide those kind of features. So they had their set of features when it's come to their SON feature set, and as provided as the DSON. So it wasn't multi-vendor, or it wasn't real-time granularity, and also there wasn't any UE level or the machine learning functionalities used in those. Those are very methodical, process-based, and the configuration-based. And even when we come to the centralized SON, as I discussed earlier, it's only few players, like even with the traditional players that they had on their own centralized SON solutions, they also very limited with the limited functionalities. And this centralized SON geography, or the deployment, especially when it's come to the multi-vendor scenarios, are very political. Because why I say that, let's say there is operator is purchasing the centralized SON from vendor A, but his RAN solution is provided by vendor B. Let's assume that scenario. So what will happen is, usually in all the optimization or the services contract, the agreement between the RAN network provider and the operator, there are some agreement, okay, these necessary KPIs, I will be maintaining these certain KPIs. But what will happen that as soon as that you have purchased a centralized SON someone else, that vendor A is saying, now you are optimizing using not my solution, someone else's solution. So I can't guarantee the KPIs that I agreed before, since that you are using the CSON. So it's always pushing to use the RAN network vendor solution as the centralized SON solution as well. So this is one other reason that there are very limited the CSON solutions are deployed among region. Like if you take the Asia Pacific, only what I have seen is only few tier 1 vendors are having those. That's the same for the geo-based SON as well. But if you compare the RIC solution, it comes with multi-vendor functionality, real-time functionality, and the standard compliance, which is the most important part. So it encourages that the diversity, multi-vendor scenario. So that's what significant change, the difference between the compared to the traditional and the new RIC domain when it's come to the network optimization. So now I'm going to little bit of further details of the RIC architecture, especially to indicate like what type of things that we can do and what type of information that it would be collecting. Okay, so E2 nodes and the E2 functionalities in the RIC. Let me describe little few of the buzzwords here, which is important when we are understanding whole the concept. So if you see this, if you see the near real time RIC, so all the interfaces that connect into the near real time RIC is called E2 interface. So you can see that near real time is talking to CUCP, CUUP, and also the DU. So all this E2 interface terminating functionalities, we called it E2 nodes. So DU and the CUCP and CUUPs are called E2 nodes. And every time that when you are talking between the E2 nodes and specific X app that we discussed earlier, that near real time has X app in it. So every time that X app is talking between these E2 nodes using very specific contract, or that the E2 nodes and the X app as having an agreement, okay, I need this information, and you pass this information in this granularity, and you pass this information every 1 second or every 2 second kind of agreement is there between the X app and the E2 nodes. So that agreement called E2SM, which is E2SM, and this E2SM has three different agreements, or the 3 different categories. One is the KPM, which is the key performance measurements. It's always that you are collecting information from these E2 nodes. So this calls E2SM KPMs. And then we have the CM configuration management. And then we have the IN, which is the interfaces. So there are 3 categories of these, the service frameworks of the E2SM. So here I'm showing mainly E2 nodes, the KPM, or the key performance management related functionalities. So what is happening is that you are collecting information. So one information that we are collecting. So examples are cell-wide PRB utilization. So how many resource blocks are utilized within these cells, and what are them, and what are the cells that the resource block that are not utilized. Then number of active users within the cell, and specifically what is the modulation level, like how many UEs are having the higher modulation level, how many UEs are having low modulation level, and what is the rank. Let's say that when you say the rank, it is like specially driven by the multi-input, multi-output, which is the MIMO. So these kind of functionalities, to provide this kind of performance, like you need to understand how much already utilizing and how much resources are remaining. So that's where this collection information matters. More than that, I indicated earlier RSRP, RSRQ, SINR. So these are the 3 major categories that you can understand the quality or the performance of any UE. So if you via the E2 interface, you can collect this information per particular UE. So that is massive information. Let me elaborate a little bit more why I said this is massive. Because for the same task, since that earlier from the traditional it was hard, I won't say that we couldn't collect this information. Of course, we could collect, but it was hard to get out to the third party application via the traditional base stations. So what operator did to collect this information earlier is having the drive test. So if you have heard the term drive test, what it does is like you the operators pay for some companies that the companies have different UEs, and you just drive throughout some cities and collect or the log information like how much is signal level, quality, and the strength that I have received when I am driving towards that city. So you can imagine like how many UEs that you required, how many mobilization team that you required, and how much time consuming. So that's the beauty, that now you can collect this real time and you can process in real time using AI and machine learning. More than that, now you have the data bearers allocation, and also the data packet allocation or the bit rate allocation. Kind of all this detail level information can be collected via E2 interface. So since that it is collecting, that's why this everything in bracket, it says KPM, key performance measurement. So it's keep on measuring and send it towards the near real time. So this slide that is indicating what control function, that is the other E2SM function, the controlling. So what type of control that you can see? That you can see that the arrow is towards the DU or the baseband side. So now earlier that you collected information, and now inside that you have analyzed it, now that you are sending the information back, or control indication back towards the DU and the CU. So what type of changes that you can do? So let's say one is that controlling the bearer. So let's say the good example is, especially when it's come to the 4G and 5G, that you have data bearers, one via from especially the NSA configuration, you have one data bearer via the LTE leg, the other data bearer via the 5G, via the 5G. So now the real-time trick can analyze which one has more traffic, whether 5G arm or the LTE arm. So if we have a UE, new UE is trying to get more data, so whether I should direct it via the LTE bearer or via the 5G bearer. So that kind of information quickly can manipulate it towards or the indicated towards the baseband via the near real-time RIC. So the radio resource allocation, so this is the scheduling parameters, how many resource block that I should allocate to these people. So probably maybe like when there is a UE at the cell edge, their performance is really low. So sometimes you can't allocate many radio resources towards the cell edge. But sometimes, like if those UEs are mobilizing within very fraction of second or very limited time, the situation of those UEs could be changed, so that UE might be moved to a better coverage. So now the real-time RIC understand, yes, this UE now have moved to a new location. I can quickly allocate the more resources towards this UE. That kind of fast changes or the quick changes, improvements can be done via near real time. The other interface that we have is the ORAN interface. So ORAN interface is always goes via SMO. So I earlier discussed as well. So SMO is mainly configuration management. So the other main thing is earlier that without even the non-real-time RIC, that we had the SMO, we talk about it. So we have the configuration indications are going towards the even the near real-time RIC or even towards the baseband. So those configurations usually is permanent. So let's say that I'm sending a change that my handover threshold, I'm a little bit discussing like different parameters involved in the handover in my couple of my later slides. But let's consider for the moment to happen a handover that you need to configure multiple different configuration parameters. So now as an improvement, non-real-time RIC may be indicating the SMO you need to change parameter A to value B. Let's say there is a parameter called handover interval, handover timer. So handover timer, let's say that current configuration is 1 second, and now he says like probably the best value for this handover timer is 2 seconds. So non-real-time RIC may be indicating that yes, go and change the value of the handover timer to the 2 seconds. So that kind of indication is going via SMO, via ORAN configuration management interface. So this ORAN interface is also part of the 3GPP as well. If you move to the A1 interface, this is new. So this comes with this RIC architecture, because A1 interface is between the non-real-time RIC and the near real-time RIC. So this interface is really important. So let me give you an example to explain what exactly the A1 interface activity would be look like. So you imagine a game, any game that you like. It could be cricket, it could be football, it could be tennis, or it could be rugby, any kind of game. And you have set of players at the ground. So players has information about the other opponent, other team, and get then and there information during the play. So the players are reading the game, the weaknesses and everything while the game is happening. So that's the near real-time RIC functionality. So probably the captain and the senior players draw up then and there strategies. For this moment, I should play like this. This moment, for this player, I should attack like this. So this information or this processing is happen real time by the players at the ground. So it's more similar to near real time functionality. But there is a set of people outside the ground, especially the coach and probably the data analyzer. Like when you come to the rich teams, like you have separate data analyzers, and who has lots of previous information and lots of information regarding the previous weaknesses or the player weaknesses and the strengths that analyze for that particular game. So while that they are in the bench or in the watching, they are watching outside the ground, the coach might be understanding or providing some making some key decision for now on that we need to change our game in this way. So he may be sending some of those messages to the captain in the ground or the team in the ground in some method that they are using. So that's the analyze level that non-real-time RIC do. Like he collects the information, past history data, and process, understand how it behaves in different time frame. Like especially when it's come to the RAN, there are some let's say it's a school holiday, or it's a school is the situation in near to a school when the school is happening or just after school finishes is completely different to the nighttime. Nighttime there might be no traffic in the near to a school, and maybe while you are having that, there would be a major function happen in the school for that particular day. So maybe that has happened over the years. So non-real-time RIC knows okay, maybe in the December that there is a special function at this particular time frame. So you need to allocate much more resources towards this school function or school area. This kind of information are the past information offline processed and passed into the near real-time RIC. And then near real-time RIC can make more educated guess based on their current performance that collected today or this moment. So that's mainly the A1 functionality, what it does. Let's take an example. Let's take the easiest example when it's come to the RAN optimization. This is one of the key optimization that we need to do every day. Make sure the handover functionality is super in your network. Otherwise, it can degrade the performance of especially the users in the cell edges. So how usually happen a handover, or how a base station direct and handover function? You have the serving cell. Let's say I have a UE, so I am getting the signals from this this P1 signal is that what I am getting. Always my signal is higher than the other signals that I have what I get in the particular cell. So that's why this become the serving cell. But when I'm moving out from the cell from the middle of the cell towards the edge of the cell, my signal strength getting down, getting lower, and probably my adjacent neighbor radio base station radio signal is getting much more and more powerful. And there is a one occasion that my neighbor cell or the target cell radio strength power is getting much more than my serving cell. But just because of your target cell is better than your serving cell, the RAN functionality doesn't allow you to do a handover towards the target cell. That's mainly to avoid the ping pong functionality. That means like if you don't have any precaution, like your radio functionality or the radio signals are not very unique, like it could be very fluctuating. So the UE would be changing between this P1 and P2, like we call it ping pong function, which would be very bad or the very worst experience for our UE. To avoid that, we introduce certain parameters. The one is the histories. That means like you need to the target cell the receive power should be greater than some certain dB, let's say 5 dB better than the serving cell. So this is one parameter, and you need to keep that it could be higher than that particular threshold for some particular time. That is the handover timer that we call. And if you are maintaining this threshold more than this time, now you are kick in, okay, now we should do the handover function, and within this some time frame that you are doing the handover function. So to optimize, we are changing this histories timer and also this handover procedure. There is a timer here that you can, these are very basic 3 functions that I'm showing, but you can manipulate that depending on the cell performance to make sure that there are good smooth handover within that cell. So let's see how it could be applied to our RIC functionality. So we have our baseband or the radio, and now we are trying to do a handover, and we have our SMO non-real-time real-time RIC. So first, that non-real-time or the SMO is collecting the information from the baseband to understand the set of UIs for that particular cell, what is my level of experience when I'm doing the handover, whether what is my radio RSRP threshold values, and whether I have neighboring cells that I can hand over, and how many UIs seeing the target cells, and what are the radio, what are the what is the signal level of these UIs target and the serving cells. So all this information is collected by the non-real-time RIC. So it will process and indicate to the SMO, like in the offline. This is not happening now, so it will be collecting towards like multiple weeks, and post-process and indicate to the SMO probably the best value that for the delta gap between the serving cell and the target cell. So today you have 4 dB, but the best value is 6 dB. So that kind of information or the indicator happen via the ORAN interface. Now that has been changed, and now the same information is indicated to the near real-time RIC as well. So near real-time RIC now measuring what is my current performance of my UIs. I have the indication from the non-real-time RIC. You need to indicate to the 6 dB, and I have the SMO function change that parameter to the 6 dB, whether I am getting the improvement. So that is what he's analyzing. Even though, let's say 65% of UIs has improved the handover performance, but there are, let's say, 5 or 6 UIs still keep on dropping the handovers, or the handover successful rate is still not good for some particular UIs. So that part is indicated or understand the near real-time RIC. And he is analyzing which UIs is that, and try to indicate to the DU and CU, you need to change back that 6 dB to the 4 dB just for this particular UIs. So how you are indicating to that particular change to that UI. So there are multiple messages how the base station is indicating the UI, your threshold value should be changed. It could be radio resource reconfiguration message, or it could be a SIB message, or it could be an interval SIB message. So there are multiple procedures that how you can indicate to a particular UI that is particular change to manipulate the radio procedure. So in using that one of those methods, near real-time RIC would be indicating to the DU, please indicate the UI that you need to operate using this particular values to improve your performance. But since this is near real-time RIC, those changes might not be permanent. That would be only for that particular occasion, that particular scenario, or that particular use case would be.